So let's talk about how to calculate a galaxy's distance from Earth, starting with a really important measurement called the galaxy's z-value. Suppose that we are observing a galaxy and it's moving away from Earth. There are two ways that we need to think about the light from galaxies. We need to think of it in terms of the light that's produced by the galaxy. We call this the emitted light. And we need to think of the light after it's traveled through space and reached us. We call this the observed light. We know that hydrogen produces a strong emission line at 486.1 nanometers, and we can find this emission line in any galaxy that we look at. Well, we can use this emission line at 486.1, or any emission line that we want to serve as a baseline to determine how that galaxy is moving. Let's say we measure this emission line in a galaxy, 46.1 nanometers, and let's call this galaxy Galaxy A. We know that the emitted light from this galaxy includes this emission line at 486.1 nanometers. But in the observed light, by the time that that light has traveled through space between that galaxy and Earth, we find that same emission line at 487.9 nanometers. The difference between these two values is positive 1.8 nanometers. The sign is important because it tells us what direction the galaxy is moving. In this case, the observed wavelength is larger than the emitted wavelength, so we give this difference a positive value. By taking this positive difference and dividing it by our baseline value of 46.1 nanometers, we get the value positive 0.0037. This is called the galaxy's z-value. Since the z-value for Galaxy A is positive, it means that the galaxy is moving away from us and so has a redshift. Between being emitted by that galaxy and traveling through space and reaching us, that light has been stretched out. Now suppose that we're observing a different galaxy. Let's call this galaxy Galaxy B. And in Galaxy B, we're observing the same emission line in hydrogen, 46.1 nanometers. But by the time that that emitted light has traveled through space and been observed by Earth, instead of seeing 46.1, we see a value of 485.8. This gives us a difference of negative 0.3 nanometers. If we divide 0.3 nanometers by our baseline frequency of 486.1 nanometers, we get the value of negative 0.0006. That's the z-value for Galaxy B. This negative z-value indicates that the wavelength of the observed light is a little shorter than when it was emitted. What that means is that the light has been compressed. This indicates that the galaxy is moving toward us because the wavelength has been shortened.